This video deals with 9.3, talking about logarithms. We're on page 2 of our notes. We're down at the bottom. Have your power card handy. We're going to try to do everything in this section without a calculator. So have this guy handy, and we're going to look up most of our answers on here. Question number 1, what's a logarithm? This happens every year. I teach logarithms. We learn how to solve with logarithms. We do properties. We do all kinds of great things. We get to the end, and I ask this question, what's a logarithm? And most students look at me and say, I don't know. So I'm going to take you through a quick tour of your math education, and when we get to the end, hopefully we understand what a logarithm is. So back in the first grade, right now I'm working with my first or second grader, you learn about good old-fashioned addition. You learn to add. So you do nice problems like this, like 3 plus 2 is equal to 5. We probably remember those days back when math actually had numbers in them and not letters. So math was easy. As soon as you learn addition, immediately you need to know how to do its opposite. And its opposite clearly would be subtraction. So what could happen is I could take these exact same numbers, 3, 2, and 5, and I could rewrite them in what I would call subtraction form. So 3 plus 2 equals 5 is addition form. 5 minus 3 is equal to 2 would be subtraction form. Or I suppose you could go 5 minus 2 is equal to 3. That's the same. But same numbers, just written in 2 different forms. All right. Fast forward to like maybe 3rd or 4th grade, and you learned how to multiply. So you learn great problems, or nice easy ones. We'll stick with the same numbers. We'll just go now 3 times 2 is equal to 6. And not long after multiplication, you needed to learn how to do it backwards, so we learned division. So I could take these numbers, which are in multiplication form, and I could rewrite them in what I would call division form. So 6 divided by 3 is equal to 2. Or I suppose you could go 6 divided by 2 equals 3, same thing. But this is multiplication form. This is division form. All right, we get a little bit farther along in our education, and we learn about powers. So you start to learn problems that look like this, like x squared is equal to 9, something like that. So you can now figure out, or if I wanted to say 3 squared is equal to 9, that would be a power. Well, not long after you learn powers, you need to learn about roots, doing the opposite. So this is right here, this would be power form using those numbers. And if I rewrote those I could write it in root form. I could write square root 9 is equal to 3, like that. So the exact same numbers, just now rewriting them in root form. Well, I think you're catching on to the idea. The next more complicated thing that you're going to learn are what we call exponential functions. Exponential. Very close to a power, but slightly different. A power function has the variable down in the base. The exponential function has the variable up top, like this, 2 to the x equals 8, like so, an exponential function. Well, for each thing that we learned, we always had a way to do the opposite. Now we get to the exponential function. And now the question is, how do I solve for this? You might, okay, if it's a power 2, if it's a square root, that makes sense. Power 3 is a cube root. What about power x? I mean, is there such thing as an x root? And the answer to that is no. What was created, each of these has an inverse. Addition has subtraction, multiplication has division, powers have roots. Exponentials needs an inverse. So what was invented, the discovery of the logarithm. The logarithm looks like this. The base of this exponential is 2, so the log that goes with it is going to be log base 2. Okay? We're going to switch up the order a little bit, and I'm going to log this number 8 like this. Log base 2 of 8 is going to be equal to x, and what you can see is that when I apply the logarithm, what happens is my variable was up here, but now I've solved for my variable, and I can figure out what it is. So now to answer that question in a very long roundabout way, what's a logarithm? It's the inverse, or the opposite, of an exponential function. It is the subtraction for the addition. It is the division for the multiplication. It's the root for the power. It's the opposite of an exponential. It will solve. Okay, that's what it is. How do we work with them? That's what I really want to talk about. All right, so first let's practice rewriting these. So here's how this is going to go. Every exponential has a base. The number that gets logged is this number over here, and when you're done, you should end up with your answer. So this right here is what I would call exponential form. You can see that I filled in, it looks like a power. I filled in the exponent so that we have all the numbers present. So if I wanted to rewrite this in log form, here's how I would do it. I would say the base is 4, so I'm going to say log, and I'm going to say the base is 4. I wrote that number a little bit lower on purpose. The number that gets logged is this one over here. It's 4096, and it's going to be equal to 6 like this. So the order of the numbers over here, you say this number is the base. So over here, you have your base. This number is what I call your answer. And what I mean by that is when we did the power, this was the answer over here. And you should end up with, if you do it, the thing that's all by itself should be the exponent. And that's how you rewrite it in log form. Pause it a second, see if you can try the next one. Put it in log form. If I rewrite it, I should have log base 6 of 216 is going to be equal to 3. Okay? Guys, if I want to talk a little bit more about logs, if I'm looking at these numbers right here, really what a log does is it answers this question. The question is, what's the exponent? What's the exponent is the question it asks. So if I'm looking at this, it's saying, all right, I'm going to start with the number 6, and I'm going to end with a 216, and I want to know what exponent will change a 6 into a 216. So it gives you the start and the end, and asks you the exponent that takes you from point A to point B. So if I want to read this one in English, it says, I'm going to start with a 9, I'm going to end with an 81, and the exponent to change a 9 to an 81 is a 2. So I can go 9 squared is equal to 81, like that. And you've got it. All right, pause it, see if you can do the last 3. Same thing here. This says start with a 3, end with a 27. Start with a 3, end with a 27, and the exponent is a 3 that takes you there. Same thing. Oh, it looks like the base is 4, so I have log base 4. The number that gets logged is 262144, and the exponent that it solves for is going to be a 9. Same thing over here. Oh, this says start with a 5, end with a 15625, and the exponent is a 6 to change it. All right, let's make the examples a little bit tougher. Now I'm going to remove a number and see if you can figure out what number's missing. And this is more what your log problems will be. So if I say log base 4 of 16, what is it going to be equal to? You might be thinking, I'm not so sure what you're asking me. But if I want to think about it in English or put it actually in exponential form, here's what it says. I want to know if I start with a 4 and I end with a 16, I want to know what exponent will change a 4 into a 16. Well, this is where your power card is handy. You can say, hey, I started with a 4, ended with a 16. Oh, that's a 2. X squared is the exponent that does that. Okay? All right, let's go next. Pause it 1 sec. See if you can try this one right here. This one says, I start with a 4. I end with a 256. I want to know what exponent changes a 4 into a 256. So I go on my paper, start with a 4, end with a 256. It looks like a 4 is the exponent that does that, so you can use your power card to figure that one out as well. All right, pause and see if you can try all these, and if you're stuck, I'll go through them right now. All right, this one's trickier. It says I start with a 2, end with a 164th, so I need to know what exponent will change a 2 into a 164th. I call this one a two-stepper. So it means that there's 2 steps in order to go from point A to point B. There's 2 steps. So first, let's forget about the fraction. How about just a 2 to a 64? I go on my paper, check it out. A 2 to a 64, it looks like a power 6. So just a 2 to a 64 is going to be a power 6. Now, what type of exponents, remember, that's what I'm filling in. What type of exponents make fractions? Or what type of exponents do flips? And if we have a negative 6 should go power 6 to make it a 64. The negative should flip it into a fraction, and we've got it. All right, next one is tricky. This one says start with a 16 and go down to a 4. Ooh, now this is kind of tricky because I'm starting with a larger number and going to a smaller number. Well, think about what types of powers make smaller numbers, and hopefully the answer that is clear. We need fractions. We need roots. Roots will make smaller numbers. So the square root of 16 is 4, so my answer is going to be 1/2 for that one. Ooh, small number to big number, this one should be quite doable. If I look at this, 5 into a 3, 1, 2, 5, right there, it looks like exponent's going to be a 5, so you can just look it up. Ooh, here's a trickier one. We're going from big to small, so I have 125 turned into a 25, and I want to know what power does that. Ooh, this one's tricky. Right away I want to say, hey, 1/5, because 25 is 1/5 of it. But remember, it's exponent. So here's what I have to do. I have to think, all right, what number kind of is connected to both of these? And there's a little bit of math sense going on here. And I see that there's a 5. So here's how this is going to go. I need to take this 125, and because a 5 works nicely with both of these, first I'm going to turn it into a 5, then I'm going to turn it into a 25. So this one, once again, is a two-stepper. So we'll go 125 down to a 5. So if I have 125 down to a 5, looks like it's a third root. So the first part of this is going to be a power 1/3. So I'll box that up. That's this first step. And now if I want to take a 5 and turn it into a 25, that's a power 2. So there's two powers that went on here. The 1/3 got me down to a smaller number, and the power 2 will make it grow. Put these together, and you have a 2/3 power. Those are hands down the trickiest types. All right, the last thing we'll talk about today is the common logs. Common logs, these are the ones that are on your calculator. So if you want to pick up your calculator and push buttons, this does work. But if you have log base 10 of a number like that, we call that the common log. Most of the time, we don't write log base 10. We just will write nothing. So if we write log of x like that, then you can assume that that's a log base 10. So when there's nothing, just assume there's a 10 there. So if I have log 10, I can say, all right, I can assume there's a 10 down here. So I can say, all right, what are they asking me? Well, it's saying start with a 10 and end with a 10. And I want to know what exponent will change a 10 to a 10. Well, hopefully it's clear, that's a 1. Got it? How about the next one? This says, okay, there's a 10 down here that we didn't write. So if I want to look at this and say, all right, start with a 10, end up with a 10,000. Now I want to know what exponent changes a 10 into a 10,000. We should end up with 5. Hopefully you're seeing a pattern emerge. Log 10 of 10. Hey, there's 1 0. We got 1. There's, oh, looks like I messed this one up. It should be a 4. Looks like there's 4 zeros. Your answer is 4, like that. And it should be, anytime you're using logs, you should just be able to count zeros if you're doing powers of 10. So your answer here should be 4. Well, this one here is a little bit trickier because this is tenths, hundredths. So if I wrote it as this, log base 10 of 100th, like that. So we should have it. We should be able to go, it starts as a 10, turns into a 100th, power x, like that. So if I'm looking at it, it should be square it for 100 and flip it with a negative, so we get -2. So if you have power 10s that are decimals, you can just you can count decimal places and make it negative. So -2 is going to be our answer. Last one with roots, it helps to rewrite this. How about if I call this log 10, the square root, I could rewrite it as a 1/2, like that. Square roots and 1/2 are the same. Here's what we should know, is that log base 10 of 10, you can say, all right, you can say starts as a 10, turns into 10 to the 1/2. What's the exponent? And we're coming up with 1/2. Or eventually, you guys are going to catch up with the rule. The logs and 10s just cancel, and you get your exponent like that. All right, that's it. And do the homework for the next time we see each other.